Hi everyone, my name is Shashank.
And I'm Prajeet.
And we've together won around 15 hackathons. And the major thing we use in every single hackathon is multiple agents running and writing code together. And there's two ways to go about it right now in the industry. The first way is about running an orchestrator agent and then spawning sub agents, and they have access to all your files. And whatever changes are made, there might be some interwoven changes together. And then the orchestrator agent has to go fix all those changes, and then push the code, and then wait for your action, right? And then the second way of doing things are this is I think what Anthropic does. The sub-agents can communicate with each other, and so that like one agent is working on something, and the second agent can know that, oh, this agent is working on something, I do not have to work on this, I'll work on something else. So even in this case, what happens is the conversation has to be fed back to the orchestrator agent. That creates a lot of context load, which again, in the long term, in the long horizon tasks, can lead to lower code quality. So we built ACG. ACG is something similar to package log JSON for parallel coding agents. What we essentially are trying to do is we search through your code base, we index the code base, and then we build a dependency tree of all the files, and then we also have a package log.json file, and the orchestrator agent, whatever model you want to use, will look over the package log.json and then decide on how many agents to spawn. And let's say there are multiple tasks to be done, and one task requires another task. So there's like dependent task for task A. So there will be just one agent going over that series of tasks. But other tasks can be like many other sub agents can work on them parallelly. So orchestrator just does that smartly.
All right, and this is the example of what the JSON file looks like over here. This is what your main orchestrator looks at before summoning the sub-agents. So how do we go about this? Unfortunately, we do not have the code map that most things such as Cursor, what else? Cursor, Windsurf, and Anti-Gravity, Codex, all those, they have something called a code map, where it is essentially the graph that we are creating that they can utilize on the whole code base that we do not have access to. So we had to jerry-rig something, and for the sake of this hackathon, we chose JavaScript to be like the main language that we're testing this on, and we had 7 different parameters that we used to figure out and make the prediction graph of sorts. And after that, what happens is we go through a bit of logic, and then we straight give it to our runtime. And how that works is we either have an MCP server, or if you're using Windsurf, we also have a Windsurf hook, right? Where, let's say that your sub-agent was given the instruction of only being able to access index.tsx, right? But due to it being over 50% context limit and it's context degrading, it's trying to access another file that is not allowed to. Our hardness will go and stop it. And this only works for if you're using MCP or R hardness. If you're going to be using a black box tool such as Devin, you kind of just have to trust that the main orchestrator takes care of the sub-agents. And the performance difference is kind of crazy, honestly. So if you look over here, we had 4 sub-agents, one of them having thinking, and 3 of them being instant, of the Gemma for 26 billion parameters quantized 4 times. And when we tried it over with T3 Stack, if any of you have watched Theo on Twitch, I guess. So what we did is we told it to go and edit the auth part of it, and it only rewrote over our own code once, while the other agents wrote over itself 4 times, and the amount of tokens we used per task went down about 42%. And the one thing that I really like about the way we implemented is we removed the human greed out of the equation. Humans usually think the more the merrier. So we always want more agents, even if that leads to code degradation. The way we go about this does not allow that to even happen. And we had this tested on another JavaScript code base, where it actually led to a 54% increase in token efficiency. And that's like the general gist of it. Do you guys have any questions?
Thank you for the presentation. I was wondering if you had any example use case that you can share as a demo.
Oh, as a demo, no, unfortunately, because we didn't have fast enough inference, all of this is like done previously. but I can give you like examples where you could probably use this. So let's say you have a huge monorepo of one of your companies, right? And the biggest limitation we had is due to the hardware. We only had 32,000 context size for each model of ours. But let's say you had something like Gemini, which is like 1 million parameters, right? So you could use that, and you could, logically speaking, the way we're implementing this, the larger the code base, the better the outcome should be, right? Because the more agents you spawn, the more overlap it leads to, and the larger the code base, the more agents you'll be spawning in. So that is like one of the few things where if you have a large enough context window and a large enough code base, I think it's going to cancel out a lot of the token stuff, and we completely diminish this problem. Is like, I think, the main selling point.
Thank you.
Any other questions?
How is this different than like the Ralph methodology? Are you familiar with that?
Isn't that when it keeps feeding towards itself?
Yeah, but you generally do one at a time. Task.
We still do have a section or a kind of parallelization going on, right? For example, let's say I have my backend and my frontend, and they're not talking right now because I have something like Postman in between that's acting like a moderator and writing the contract up that both the frontend and the backend will be using. Then I can parallelize with 2 agents. But had I had to loop, I would still be only 1 agent going at it, if that makes sense.
Okay. And you're writing the context out some like a year in between.
Oh, that's a beautiful part. It figures that out on its own, right? Your main agent is smart enough to figure out what it needs to do. We just give it the tools that tell, okay, even if you think it's optimal for it to be 5, it really isn't, because that's going to lead to these files being overlapped, which is something that most agents don't really think about. And because of that, the smarter model itself will only pick 2 agents, which is like the most efficient way to go about it. So this can run anything. It's model agnostic. You can use it on Codex, Cursor. If MyThreads comes out at some point, you can use it on there too.
Okay, thank you.
Anyone else? All right, thank you.
Hello everyone, I'm Kevin.
And I'm Jay.
And today we want to talk to you about something really important. Right now in the United States, if you're a business owner, you can expect that more likely than not, your business will be affected by a software supply chain attack, right? And that's because, truthfully, our software and our software teams were built in a world before AI and before agents. As attackers become more intelligent, more capable with agentic tools, we need to find solutions that beat them to the punch. That's why our project is Codebreaker. It's a agentic harness dedicated for cybersecurity, so we can find these vulnerabilities before they're exploited.
So the first part about building a good agent harness is how you're going to evaluate it. Unfortunately, existing cybersecurity benchmarks used by frontier labs like OpenAI and Anthropic are oversaturated. Their baseline models can already perform very well on these benchmarks. And a lot of these benchmarks are also overspecified on specific attack vectors in cybersecurity, for example, C++ memory leaks. And so we wanted to build our own benchmark, curating 30,000 open source vulnerabilities from online repositories like GitHub, and filtering them into tasks that our agent can basically run against to test if it can try to find a vulnerability in a code base.
Right, so how are we actually running this benchmark of ours? So we built a platform here on top of Modal for sandboxing and containerization, and Cloudflare for infrastructure and scale. And so what this allowed us to do over the past 36 hours was to process over 300 million LLM tokens and legitimately validate our benchmark across a variety of different models on a variety of different vulnerabilities in open source repositories. So for instance here, we're able to run a bunch of benchmarks simultaneously without worrying about running into rate limits because of our tech stack. You can even see here one example of a benchmark we've completed demonstrates how a model is provided a task, which is identify a specific vulnerability in a specific file, and it evaluates whether or not that model had the ability to reason and identify that specific file, as well as the specific region of code where that vulnerability lies.
Yeah, so to go back to our main point about building a better agent harness, we put our agent harness on an open source model, Kimi 2.6, and here we can see that it performed with a score of 0.47, and if we compare that with the unharnessed version of a score with 0.35, which is around a 33% improvement, we can also see that it performs relatively well to other frontier models like Gemini 2.5 Pro and OpenAI GPT to find these security vulnerabilities.
So once we have a harness that is evaluated and is capable of identifying these vulnerabilities, like what do we actually do with it? So our platform also includes a way to run audits against open source as well as closed source closed source repositories to identify these vulnerabilities. Our harness creates various different specialized sub-agents to focus on specific vulnerabilities, say in auth or SQL injections, or any number of different areas that you might be concerned about. Once each sub-agent runs, it reports various different vulnerabilities or issues that it detects, which the model then further validates. In fact, one example of where our harness was actually able to be very effective, the judges in the audience will recognize this platform, is Jury, which is how LA Hacks is run. Our model was able to identify a vulnerability in the judging platform that would allow creation of judge accounts without authorization. As people who have run hackathons and work on open source at university, we know how hard hackathons and open source is, so we have all the respect for everybody involved here at LA Hacks and in the development of this platform. But I think it goes to show how much of the software we depend on every day may not be so secure as we would like to think, and how tools like Codebreaker are able to level the playing field and make sure that these things are identified before they're a problem.
Yeah, so the next step after our agent harness is really good at identifying vulnerabilities in code bases. But the next step to that is actually triaging them. And so we run our Devin agents to open up PRs. I'll click this one, for example, which has already been opened. And we can see here that it opened a PR to close a vulnerability in the Open Cloud repository. Speaking of Devin, we want to shout out Cognition for being great sponsors at this event. And also thanks for all the compute credit. We use Devin a lot in various parts of our project. One, as a researcher, for our benchmarking, we benchmarked over 500. We benchmarked over 500 agent sessions. We used it as a security engineer to triage issues, and we also used it as a software engineer. You can see here it had over 32,000 lines of code committed, as well as 400 PRs, and our total repo was around 1.3K commits. And yeah, that's Codebreaker. Thanks for listening. Happy to answer any questions.
Right, so this looks like a cohesive demo. Thanks for the demo. Where do you think you're going to take this product from here?
Yeah, we think cybersecurity is only going to get even more important. Even prior to releases of models like Anthropic's Mythos, we were starting to see frontier capabilities in stuff like GPT 5.4 or Opus 4.6 really push, I guess, our perception on how secure open source software and software as a whole was. And so we think where we see Codebreaker going, right, is ingesting more vulnerability data from open source, working with closed source partners that have a trove of historical data, and building this sort of data flywheel that will enable the model to be, or the harness, to be even more effective at identifying vulnerabilities and protecting our open source supply chain. Thank you.
Thank you. And how do you, every time you benchmark, are you running it all the time? Do you have to, does it automatically scan through whatever benchmark, the repos that you were scanning? How do you set the benchmark to be more accurate and up to date?
Yeah, that's a great question. So for this hackathon, because this is the first time that we had aggregated so much vulnerability data at this scale, we ran it once, which was, over the course of 36 hours sufficient. But I think you hit on a really great point, which is that cybersecurity increasingly cannot be defensive. It must be proactive, right? And systems like Codebreaker will want to ingest vulnerability data as it comes up, continue to improve our threat model as new model capabilities, new attacks arise, and just continue to be a great protector of the ecosystem.
Great, thank you.
You noted that a number of those PRs were closed. I'm curious to know how many of those were merged.
We can actually just pull up the repo and check. But I would say the majority of those are actually merged in. Let's see.
Yes.
Yep.
So I think that the vast majority of Devon's PRs were merged into the repository. A lot of it was used for our data collection, as well as to help improve the repository as we were building, keeping the system clean as we were, grinding away tokens.
All right, great.
Thank you so much, everyone.
Sorry, I have one more. So if you had a few more hours, what is the one thing that you would have done on top of what you have for your part?
Gosh, I think Jay and I could probably go on and on about that. We talked a little bit about that active threat model. I think that truly is where we would want to see this. We want to further test out this harness. We want to compare it against harnesses like Claude Code or other security tooling, right? And really put our money where our mouth is and demonstrate that open source models and an open source harness really can compete with the best. Thank you.
Thank you.
So for the next 5 seconds, I want everyone here in this room to stay completely silent. That feeling where you have something to say to someone who's right next to you, that's something that thousands of people across the globe cannot feel every single day. And that's why we built iText. Okay, raise your hand if you've ever sent a text. Yeah? All of us? Great. Okay, keep your hands raised if you can send a text without using your hands. Oh, a lot of people. Okay, great. Okay, we'll present another way to do it.
Hi, welcome to our live demo. This is our page. It's like a web app we created. The web app is about iText. We have something called Start with Webcam. So we start with a camera and then it opens up.
Here, we're basically trying to calibrate the user's eyes according to the dots, and that will basically help us type, but using his eyes. So we're just making sure, and now we do have 2 modes. We're entering the talk mode. It does get a little bit slow because the calibration takes a while. Okay, we're in, great.
So if you notice, he did not use his hands at all. All he's doing right now is looking at the screen. So he's looking straight at what he wants to click, and if he looks at it for enough time, in this case 1.3 seconds, it's going to select that option.
Help out.
And we see that
Urgent. John needs immediate assistance.
Great, it worked, guys. Okay, now let's move on to the more emergency and assistive system that we have built in. So while he's looking at the food, obviously the agent thinks that he needs food. Yeah.
I need to use the bathroom.
Yeah, okay. So our goal is to help. This is used basically to help people who are hospitalized or bedridden, and it's for people who who have cognitive decline or motor impairments where they can't verbally express what kind of issues or what kind of assistance they need. So it helps them to ask help or even get communicate with their loved ones using their eyes. So it's also really helpful for people once they cross the age of 55, because there's a 42% chance of most Americans
Americans like having a risk of developing dementia, and it's really helpful for people with that because you start to you start to lose your mobility, and the one thing you can rely on is like rapid eye movement. So I think this is more consistent as a form of like communication if you in such conditions.
And moving on to how this works technically, you guys would have noticed that we have a webcam on the laptop, which is how we interacted with it. And this connects directly to our gaze engine, which we created. What this does is it looks at what he's looking at to determine what he wants to select. And we fine-tune this to make it as accurate as possible. You also would have noticed the predictive tiles which we have. And we'll notice that whenever he selects a word with his eye, it's going to output 4 new tiles with 4 new words that he can choose next. These are predicted based on both personalization, so it looks at the past conversations he's had with the agent. So it knows who he's talking to, what kind of conversations he has, what kind of things he likes to talk about. So we know that, okay, if he's talking to his daughter, he probably, if he says I, then the next word might be I miss you, or like I love you, something like that. So we want to make sure that it's tailored to him, but also it looks at the current sentence we've built up to date to look at okay, like using Gemini and like our Fetch AI agents, we can determine that these are the things that he probably will say next.
Yeah, just diving deeper into the backend, we used Fetch AI for most of our agentic work. We had one agent just store a lot of information about the user. For example, in this case, it was John, who was a father, and Mary, who's his daughter or caregiver. So as you can see, it's very context dependent. Say you're talking to your coworker. With I, you would probably say, oh, I need help with this. But if you're probably talking to like your daughter, you would say, oh, I miss you, or I love you, right? So that's something we integrated into our model. We also have like a model that sort of determines the urgency level of the message. If he types help, help, help multiple times and sends it, we will have the agent blast out a more responsive and more immediate message.
Do we have any questions?
I have 2 to go with. So first is, how do you work with call start? Because you said your model is predicted based on past conversations. So how does a call start work?
So for co-start, unfortunately, we'll have to work on most probabilistic models. So like maybe like I, or like, you know, I'm going to like these kind of things that people usually start conversation with. But the good thing is that once we have a bunch of conversations in the past, we're able to store that information and personalization we have about the user in MongoDB, and then start based on that with more effective answers.
Are you trying to generalize or train the model across patients, or is it just personalized for one patient?
So we're currently personalizing it for the particular patient because we're creating entire like user databases. Yeah.
And then in your flow, how do you recognize who's the person the patient's talking to? Because based on that, things change. How do you input that in the demo that you just showed us?
Right now, we don't have any explicit thing to be like, I'm logging in as this user, but we will use contextual clues. So like if you're like, Sarah, I want to do this, then you know that you're talking to Sarah, and we can associate that with your previous memory of like when you were talking to Sarah. But in the future, when we make this a proper product, we might consider like, okay, like I'm John and I'm talking to Sarah, and now I want to like have contextual elements based on what I know about her.
Just to understand, just so I understand this, you're saying that even the names and the users that they interact with is going to be in your flow. That's how you're thinking of it?
Yeah, that's right. To make it more personalized and have more effective responses.
Cool.
Yeah.
Thank you.
Hi. This is of course going to be very useful for people who cannot use their hands and voice. How do you think they would go about the calibration process? This is of course a demo, but when you go into a product phase, how would a patient go through the calibration process?
Okay, so we were thinking that we would have a caregiver initially guide them through everything. As you can see, even while he was doing it, he did have to like manually click on the buttons to configure all of the points. And to add on to that, just for the demo purposes, we had only 7, but we are going to make it like even more randomized, appearing at different spots. And we would have an onboarding process. We're also thinking of like a small questionnaire to understand more context about the user.
Got it. So it's a one-time calibration for life?
Yes.
That's right.
Yep.
just wanted to say thank you for selecting us. This issue was very personal to us. Being a student, we all have grandparents, and then it's tough for us to like communicate with them. I think so. We wanted to solve this issue and bridge the gap between that. And I think that was the idea behind this project. So thank you.
Thank you.
All good to go? How's everyone doing today? Just want to quick throw a question here. How many of us use some agentic tooling today? It should be all of us. I know we're all vibe coders. Follow-up question, how many of us asked these agentic tools a question we've already asked before, but it took a long time for some reason? You know, it's going through our repositories, it's going through all our files, it's grepping, changing directories. It's being redundant. We had this problem this weekend, and we really want to focus on fixing that. That's why in 36 hours, we made one line of code. I'd be lying a little bit if I said that, but we made a kernel command for you guys to run and download our plugin. Our plugin is so good, it takes state-of-the-art agentic tools and decreases the inference time by 200%. I'm Alan, this is Adarsh, Ryan, and Caleb, and we are Alpha Sun.
Yeah, awesome. Just like Alan was talking about, there's so many amazing agentic coding tools right now. Claude, Codex, Windsurf. There's one kind of problem though. They're all stuck in a maze. You can clearly see they all go loops. They all do an exhaustive search to try finding the solution. But what if there was a map of every single wrong turn it made to make sure it never makes that wrong turn again?
So what is the perfect interface for this kind of application? We decided to go with OpenCode, and maybe you guys know or heard of it. It's an open source alternative to Codex and Claude Code, and the reason for that is that it releases its traces and its thought process. We need to ingest that, and we use that in order to understand user sentiment and when rejections happen, and that helps for future models.
Yeah, so technologically, the main thing that we're doing is we're taking that entire trace in and we are searching for rejections. Rejections in this case are going to be things that can be a bit empirical, like linting errors or type checking errors, or they can be a bit more like how probably all of us vibe code, where it spits something out and you go, wow, that's terrible, change it, you suck. If that's the case, we do a little bit of sentiment analysis to determine that you aren't happy, that you're dissatisfied with it, and we use that to track a rejection. What happens with the rejections, however, is I think kind of the magic of our tool. So like Alan said, we really want to take those failures and use that as our blueprint to succeed in the future. So if you want to go ahead and open up the graph here. So with those rejections, we go ahead and build this graph here. I know it looks like a lot, but it's not too bad if you think about it. Pretty much, we take the agent, we take the issue that it had, or that it failed on, the symptoms from that issue, and then a suggested fix for that issue, and we graph that all in this big graph here. This is kind of where the magic happens. Every single call past this point, we consult this graph with a cosine search on our vector database to find a similar node to the user's new issue. Once we have that, we start at that node and do a graph search around the graph from that node, and we go ahead and gather all the context related to that issue. And then instead of just dumping all the context directly into the prompt, and blowing up your input context window, we go ahead and do the opposite, where we try to cut down on the output context window instead. So we take that little bit of context that we got from the graph, and we inject it specifically into the tool call right before it would normally go ahead and start searching your entire code base and repeating itself. And with that little kind of push over the edge, we've seen just amazing results from these models, able to immediately just skip most of their tool calling and put out an amazing solution with much better results than without the graph. Alan can tell you a little bit more about the stats we've been seeing.
Yeah, so testing with Anthropic's Claude Haiku. It's its worst model. We went from a 3-minute inference time, and using our plugin, we got it down to 1 minute and 6 seconds. Now going to the state-of-the-art Opus 4.7 that we all know takes up our sessions and we aren't able to code anymore. We got that down from over 80 tool calls to down to 6. That is so much cost in tokens, inference time that you can't get back.
Awesome. Yeah, we'd love to open up to some questions if anyone has any.
Hi, thank you. I have a lot of questions. So I'm curious, is this going to be on a project basis? And how does this graph develop as you continue working on something and you have a huge repo? Is that actually going to slow things down? And then I have another question, which is, I mean, one project's failure might be another project's success. So how would this maybe work in a bigger company, or even for somebody that vibe codes and doesn't have a technical background? Like, is there something they could learn from this?
Yeah, no, absolutely. So we built this entire thing with enterprise in mind. The main thing right now with that curl command to install it, installs to just your project, everything runs locally on computer, we track nothing. But at an enterprise scale, all you have to do is host that database, the Postgres database and the vector database, up in the cloud, and you can share it between your team, your project, even an entire organization if you want to. As for kind of scope creep, like you mentioned, that would be, we have some temporal weighing. So if there's an issue that hasn't been resurfaced in a while, the confidence that that is going to continue to resurface starts to slowly diminish, meaning we populate it to the user less, and thus don't inject anything related to that one as frequently. Past that, I mean, we do have an archive system where, so say your coworker gets a promotion, great for them. Now you're stuck with all their work. They can export their entire graph of information right over to you. You can import it into yours, and immediately you have an agent that knows all of the issues that they've been facing and can pick up right from where they left off, and hopefully save you a little bit on that, Claude code, that quota there.
Maybe I missed it, but are you only saving like the tokens of the prompt, or are you also including the context in the knowledge graph you're creating?
Yeah, so the graph itself is specifically which agent spawned the task, what the error categorization was, the symptoms of that error, and then a suggested fix. The suggested fix is the only spot that we have external latency. That's from just a small Gemma call to Gemini's API. But everything else is just embedded into our vector database, and then we use that for the cosine similarity.
Could you tell them about how you're handling the subjectiveness?
The subjectiveness?
Because you do take input from the user, right? So
yes.
I could be very pedantic, another person can be different opinion, and how do you handle it?
Yeah, so that's kind of the best part of the tool in my humble opinion. What we ended up doing is we don't force the model in any way. We don't force the agent, we don't block its tool calls. Even our prompt injection, that little like surgical injection we do, is super loose. We don't say like you have to do this or do this before you do this. All it is pretty much, hey, you've seen this issue before, and last time it caused these symptoms, and you solved it like this. Be cautious and just kind of double check your work. We noticed throughout our testing, that's really all of most of these models need, is just a little push in the right direction, and you just see just incredible improvements right off the bat. Thanks so much.
Thank you.
Hi, I'm Krish.
I'm Varun.
I'm Audie.
And I'm Srini. And today, we're here to present RISE, Rapid Incident Intelligence System. So the problem we're trying to solve is a very relatable one for all Californians. It's about earthquakes. Earthquakes, as we know, cause a lot of damage. They destroy buildings, rubble is sent everywhere, but most importantly is the fact that there are survivors that need treatment instantly in almost all of these situations that don't get the help that they need as soon as possible. As we see here, 72% of structural collapse survivors die waiting for the safe EMS entry. And that's because it takes a while for the first emergency responders to navigate through a tough environment with lots of obstacles and surroundings and actually make it to the survivor. So our project aims to solve that using edge robotics and virtual reality.
Yeah, so let's get started with the robot. So here's a robot. I'm sure it's kind of challenging for y'all to see because it's kind of far away, but yeah. In the front of it, there's a camera. Just keep note of that. I'll be explaining that a little bit more in detail in a bit. So unfortunately, we can't really demo it here, but we have a demo prepared for y'all. And we created our own environment. As you can see, there's like rocks and leaves and stuff. So let's give it a run. So right here, as you can see, the robot's navigating through the pathway that we made, and it's avoiding obstacles like the rocks. It's an autonomous loop, automatically moving through obstacles on this path in order to find and identify. So right here, as you can see, the robot started to find the survivor right here, Srini. And as the robot approaches and once it detects the survivor, it starts to speak to the survivor essentially. And in this sense, Srini is talking in Spanish. So the robot talks back to him in Spanish and communicates back and forth. Identify survivors. Then our robot communicates with the survivor in their native language.
Sobreviviente localizada. Mantén la calma. Soy un robot de rescate. Los equipos de emergencia ya tienen tu ubicación. Por favor, responde. ¿Puedes oírme? ¿Cómo te llamas?
Me llamo Srini. Mi abrazo no puedo moverlo.
Srini, te escucho. La ayuda viene en camino. ¿Estás atrapada? ¿Puedes mover las piernas?
No estoy atrapado, pero hay escombros y mis piernas están bien.
Bien hecho, Srini. Mantén el brazo lo más quieto posible. Los rescatistas estarán contigo en pocos minutos. No estás solo.
So as you can see, the robot and Srini had a back and forth conversation. And one more thing to note of, like I mentioned before, is the camera. So the camera constantly takes live footage of what it sees, and it pushes it to the back end. So let's take it to the back end now.
All right, so here's a better look at our backend that is tailored for first responders. So as you can see in the top left, the model that we use, YOLO V8, it casts a skeletal frame onto the patient, which are all those lines that you see moving. And once it detects this patient, we use 11 labs after to communicate with this patient, as Adi said, in their native language, which was Spanish in this case. And then our Fetch AI agents work in tandem together to send a triage personal plan to the first responders. And then lastly, what I think is the coolest part of our project, while all of this is going on, we have a 3D reconstruction of the path that the rover took. So this same path that the rover took, including all the obstacles and debris, a first responder will be able to not just visualize it, but walk through it in virtual reality.
All right, so as you guys saw earlier, we went through the course that our robot took, which is through, as Varun said, rocks, leaves, debris. I'm sure you guys saw it. So first responders actually have to know how to get to the survivor that we found. In an actual environment, there's gonna be rocks, crevices, so many things that our robot has to navigate, meaning that's so many things that our first responder has to know how to navigate through. So because of that, we decided to develop a virtual reality solution here. So I'll walk through it right here with you. So this isn't reality, this is virtual reality. So if you go through here, this is exactly the course that the robot took. You can see here the Starbucks bag, the rocks, the debris, everything that was there in the original footage. The way this happened is that there's actually a pie cam right here on the robot. The entire time from when the robot was deployed to actually when the robot found the survivor, it was taking many different frames, many videos as the robot traversed it and was able to reconstruct this 3D environment. But this is just a laptop screen. I want to show you guys this in an actual VR headset. So right now I'd want to call up a volunteer, preferably from one of the organizers. So let's make some noise for one of our volunteers right here. So
So he's gonna put on the headset right here. So how about you turn this way? Just want to start. So stay right here. Tell me when you see black, because that's when we know it's all loaded and ready to go.
Yeah, it's black right now.
Okay, turn around. Start looking around. What do you see right now?
Flowers. I see some stones. Oh, I think I see a Starbucks bag somewhere. Wow.
Yeah.
Yeah. Do I get
No, you don't get free coffee, but this is what, I'll explain to you guys what's happening here. So again, a first responder doesn't actually have to be in the environment to learn the environment. They can be deployed in the environment without actually even being there through our solution right here.
Wow. This is so cool. I feel like I'm in the environment.
Give a round of applause for the organizer. And yeah, that's our entire project. We're open to any questions y'all have.
Hi, I see that this is a hardware project. What was the most challenging part of wiring everything together and setting up the end-to-end pipeline?
Yeah, so in terms of hardware, I think wiring it up itself was a little bit annoying because it was a very basic kit that we used. In addition, to get all the sensors to work perfectly always is a challenge. I was ideally wanting to use like a thermal sensor or a heat sensor because that would be perfect for the situation. But unfortunately, that's more of a large scale hope. So at this point, that was one of the things we wanted to do but couldn't really do due to the hackathon time constraints, but yeah.
Yeah, so what's going on there is that we take a video, right? This is around 60 seconds from deployment to finding our survivor streaming right here. So using that, we use a Gaussian split algorithm to extract the keyframes from it. And then using that, we reconstruct the digital environment that you guys see right here. I hope that answers your question. And just to be more specific, Gaussian splat is a transformer-based machine learning algorithm. Thank you.
Thank you so much, guys.